Hi, welcome. Today I will be talking about our ECE1548 final project, which is to deploy a software-defined based multicast onto the Savvy testbed. So multicast essentially is one-to-many communication. It allows a source to send one message to multiple destinations. What we use to enable this is OpenFlow, which is an enabler for software-defined networking. It essentially separates the control plane from the forwarding plane, and it allows users to programmatically define the logics of switches and routers within a network. So our design goal is to deploy a framework for multicast using OpenFlow onto the Savvy testbed, as well as enable essentially publish subscribe, so allow users to subscribe to a particular multicast host, and any packets that the publisher host sends out will be forwarded to all the subscribers, effectively enabling a one-to-many communication. So this is just a sample network topology, tree topology, where there are 9 hosts in total, spread across 4 switches, and something that we wish to achieve would look like this, where H7 and H9 subscribe to H5, and H5 will then send any messages that H5 sends out will be replicated and sent to host 7 and host 9 respectively. So how we do this is we use something called OpenFlow group tables. These group tables, so what these are they're programmed into OpenFlow switches, and group tables contain group entries, and which contain something called OpenFlow buckets. And the buckets essentially contain actions that are applied onto eligible packets. So for example, multicast can be achieved through buckets just by creating a bucket with the action that modifies the destination IP MAC and port to the subscriber's IP MAC and port. When a packet that enters the OpenFlow switch that is associated with the group table, so essentially when it's eligible, all the actions in the bucket list will be performed. So here's just the technical details and switch logic of the switch that of the OpenFlow switch that we programmed to do so. So to subscribe to a host, subscribers just send a ping to the particular host that they want to subscribe to. When the packet is sent out, the edge switch connected to the subscriber will first extract the IP source, MAC address, as well as incoming port number, and then it will then create an OpenFlow bucket with the action that will modify the packets to have their destination IP MAC and port numbers to match, to be modified to the extracted values that we previously extracted. The OpenFlow bucket will then be associated with the OpenFlow group, and the ping destination IP address, also known as the publisher address in our case, will then be associated with this group table. So any packets received by this edge router from the publisher will cause the buckets to be executed. So a more graphical example. So H7 starts out by pinging switch 5, which is the particular host that he wishes to subscribe to. So H7 is the subscriber, H5 is the publisher. The source IP and MAC address and the port number of H7 is extracted. A bucket is then created, which has the action to replace any incoming packets with the IP and MAC address and port number of H7. So this bucket gets associated with an OpenFlow group, and finally we associate the OpenFlow group with the IP address of the publisher, so H5. So any packets that come in from H5 that gets received by switch 4 will have all the actions executed within the bucket list. So now I'm just going to demo what this looks like. Moving on to here. Okay, so first I am going to create the mininet that we will be testing on, which is the tree topology described in this diagram here. So 9 hosts, 3 topologies, as you can see, 9 hosts, 4 switches, and then I'm going to go instantiate the Ryu switch logic. Okay, so to subscribe, so I want to make H7 subscribe to H5. I do H7 ping H5, only send one packet, and as you can see here, 7 subscribes to H5 and belongs to multicast group 0. If I were to create another multicast group, this number does get incremented. So H7, H5 again, so H9, now we want H9 to ping H5, and so the IP address of H9 is subscribed to the IP address of H5 and belongs to multicast group 0, which is the same multicast group as I mentioned before. So if we dump the group table onto switch 4, which is the switch right here, the edge switch, you should see, syntax error right there, you should see that with any packets coming in that pertain to group ID 0, have the actions where it sets the 10, so the IP address of H7 to the destination field, the MAC address of H7 to the Ethernet destination field, and the output port of host 7. And same thing is done for H9. It sets the IP address of host 9 to the IP destination, and it sets the MAC address of H9 to the destination as well as the port. Now if we also look at the flows, we now have a flow that is associated with the IP address of 5, and it's essentially actions everything in group 0, which was the group that as we saw before, anything that comes in with the group ID of 0 will action all of these packets. So I will now demo that. Let me just spawn a few terminals, H5, H7, and H9. Quickly make a Wireshark for these guys. Oops, Wireshark. I will now put this onto a different desktop, as well as the for H5. Okay. I need to start the interface for H7 as well. Don't want to filter. Okay, now when I send a packet from node 5 to host 7, H9 will receive the exact same packets. So as you can see, both are now being spammed with UDP packets. So this is just, in essence, the multicast that we were trying to achieve, where H7 subscribes and H9 subscribe to H5, and when H5 sends a packet that reaches switch 4, it gets replicated to both senders. So the lessons learned from this project is that about the OpenFlow 1.3 functionalities, such as buckets and group tables, as well as a lot of syntax that comes along with designing switch logic with OpenFlow, such as the packet handler and other neat Python functions. As well, and another thing that we also learned was to design a multicast configuration on OpenFlow. And with Mininet, we also learned a lot of things: how to create a tree topology using Mininet, how to enable the visual terminal on the Savvy testbed using Wireshark to view incoming packets, and how to send the packets to verify the multicast capabilities, which in our demo we used iPerf to generate UDP packets. So future works in how to improve our current implementation. So we wish to extend the current implementation to work on different network topologies. Currently, as you know, the edge router stores all the multicasting information, so it really only works on tree topologies mainly. And we also wish to extend the functionality to allow multicasting to different hosts to multiple hosts on different switches. So currently you can only multicast from one host in one switch to hosts under a single switch. Thank you.